Alright, this is just a supplemental video to go with just solving by substitution because we already looked at graphing and substitution together. So this one is just on substitution, just in case you need a few more practice problems. Alright, so the first one we're looking at here is an example of where both equations are solved for y. So both of them have the y value already solved for you. Let's see if I can move the pen work. Oh, there we go. Alright, so they're both equal to y. One difference here between this one and the next one that I'll show you is that this one is a horizontal line. So one of the equations is already solved for y. So now what we really need to do is to just solve for our x value. Alright, so the way we solve for x is by setting those two equations equal to each other. So we have negative 3 equals negative 3x plus 3. So we took the first equation and put that one on the left, and the second equation, and we put that one right here on the right. And then we subtracted 3 from both sides. So minus 3 on both sides. Let's see if I can clean this up just a little bit right here. And the values on the left-hand side are going to cancel out. So these two cancel. And so we have negative 3 minus 3, which gives us that negative 6. And then our last step is to divide by negative 3 on both sides, which is how we got the positive 2. And then from there, we're looking at where I was about to say where the y is, but we've actually already solved for y. So our next step is to just go ahead and write our ordered pair, which is 2, negative 3. Alright, for this example, again, they're both solved for y, but here, neither of them is a horizontal line. So now, once we solve for the first variable, we'll have to substitute back in to solve for the second one. So we're going to start this one just like we did the other one, where we set the two equations equal to each other. And then we're just going to follow the steps of solving an equation. So what I did here was first to subtract 8 from both sides. Minus 8, minus 8. These two cancel, and that's how we get this negative 16 that you see right here. And then I added 2x to both sides, and that's how I got the 8x that you see right here. So negative 16 equals 8x. To get x by itself, we divide by the coefficient, and the coefficient is an 8, so we divide both sides by 8. Negative 16 divided by 8 gives us that negative 2 that you see. Alright, and then here, I'm showing you where I plug back into the two equations. You only have to plug back into one of them, but what I'm showing you is that it doesn't matter which one you plug back into. Either way, as long as you do the steps correctly, you should get the exact same answer. Alright, and so our solution is negative 2, negative 4. Alright, and then this is the last example I'll show you on just the substitution method. So here, only one of the equations is solved for y, and this works just like the example that we did where I was showing you the graphing and the substitution at the same time. So here, instead of it being the first equation like it was in that previous example, now it's the second equation that we're going to plug in. So we look here, and this y equals 7x plus 7 is going to be substituted right here for this y value. So when we plug that in, we get negative 4x plus 6 times 7x plus 7 equals 4. And then we just kind of work through the steps until we're able to solve for x equal negative 1. If the question that you were asked is asking you to just solve for the x variable, which sometimes that's one of the problem types that you'll see, is where it's just asking you for one variable or the other and not necessarily the whole solution. So if it was just asking for your x value, you would be finished. If it were asking for the y value or the ordered pair, you need to go ahead and substitute. And there's the steps for plugging into either equation. In this case, the second equation is the simpler one to plug into because it's already solved for y. So our solution is negative 1, 0.